Hello everybody, our group name is SQL Soldiers and we made a database to reflect the UTSA catalog. Our team felt like there's no easy way to plan and organize classes. If you miss a prerequisite, you might end up a semester behind if it's required for a gateway course. For example, you might want to take artificial intelligence, but you need to take linear algebra first. Artificial intelligence is a gateway course because it is required for machine learning and deep learning. So just missing one prerequisite will push all these courses back one semester, thus delaying graduation. Our goal is to make a course planner that stores courses taken, courses you plan to take, and even generate a future timeline based on each student's needs and classes they want to take. As for main features, we allow students to create and delete their profiles. Students can then add, remove, update courses taken and/or plan to take. We are still working on implementing AI to generate a 4-year plan based on individual preferences. This is the entirety of our schema, but let's zoom in for a more detailed breakdown. Starting at the top, we have university. For now, we are only looking at UTSA, which is followed by colleges, and each colleges has their own departments. And then each department has their course. For courses, they could have one or multiple prerequisites. We are only looking at the AND variable right now, even though some courses have an OR variable. The courses also have sections, as there are multiple sections per course. Sections have terms, instructors, meetings, and enrollment. We have student credentials, which stores the student information, and then the student information has an enrollment history.
Hello everyone, my name is Matthew Perez and this is our database project. Our database models a university course catalog and enrollment system that tracks universities, colleges, departments, courses, sections, students, instructors, and enrollments along with prerequisites and their meeting times. I'll start by quickly showing the core tables and the types of data that they store, and then I'll walk through a set of SQL queries that demonstrates joins, aggregates, and CRUD operations. So let's first start by looking at the colleges table. The colleges table stores college ID, college name, university ID. Course table stores course ID, course number, course title, the credits that are given for that course, and then their department ID. The course prerequisite table stores course ID and the prerequisite course ID. The department table stores the department ID, college ID, and then the department title. The enrollment table will store the enrollment ID, student ID, section ID, and then the status of the enrollment. The instructor table will store the instructor ID and the name of the instructor. The meeting table will store the meeting ID, section ID, day pattern, which is the days that they meet, start and end time, the location, along with the instructor ID. The section table will store section ID, course ID, term ID, a CRN status such as open and close, and section number. Student table will store general information about the student, such as a student ID, their status, whether they're inactive or active, major, the total credits for the student, first and last name, along with their email. Student credentials will store the credentials of the student, such as the student ID, their username and password. The term table will store the term ID, the name of the term, such as spring 2026 or fall 2025, and the start and end date of the term. Finally, university table stores the university ID along with the name of the university. Now let's go ahead and take a look at some of the sample queries. So let's go ahead and just run all of these and we'll go over them one by one. So this first query right here lists all the sections that are offered in spring of 2026 with their meeting times. You'll see here that we have the CRN displayed along with the course number, course title, the day for which that particular section meets, along with their start and end time, and the instructor that is teaching it. The next query right here counts the number of enrollments per section. So it'll just display the different sections and it'll show you how many are currently enrolled. We have it listed in descending order. So right here at the top, we have the most students enrolled right here at the top, followed by the furthest as you go further down. So currently the most students are enrolled for programming 1 for computer scientists, and the least amount of students are currently enrolled for those 2 operating systems for those 2 particular sections, along with their corresponding CRN and course number. And then right here, we just have some basic CRUD operations. So we'll start by inserting a new student to the table. If we go to student right here and we go all the way down to the bottom, you'll see that Ryan Simon is our last student that we added. But if we run this query right here, we will insert a student by the name of test student. So go back to student table, and you'll see when we go all the way down to the bottom, test student is now active. Their major is computer science. If we wanted to change their major, we can run this query right here. Let's change it to cybersecurity. And then we go back to student. And if we go all the way back down to the bottom again, you'll see test student now has cybersecurity as their major. And finally, if we wanted to delete the demo student that we added, we can delete them. In this case, we're deleting them based on their particular student email. So we can go ahead and run this query right here. And using their email, we can delete them from the database. If we go back down here, you'll see that Ryan Simon is indeed now the last student, and the other test student was taken off of the database. So to summarize, this database supports a full course catalog and enrollment system with tables for students, courses, sections, prerequisites, and enrollments. Thank you.
For user experience, our goal was to design a database that is simple, clean, and easy to understand. We organized the schema so that related tables are grouped logically, and the structure is easy to navigate when running SQL queries or reviewing the ER diagram. During testing, our teammate mentioned that some relationships in the ER diagram were hard to follow at first. Because of that, we reorganized the layout, improved table naming, and made the schema more readable. This feedback helped us make the database easier for new users to work with. One major challenge we faced was modeling course prerequisite. Real catalog often use both and or logic, and supporting that kind of complexity would make the schema much harder to maintain. Another challenge was ensuring data integrity, especially preventing duplicate enrollments and avoiding foreign key errors when inserting or deleting data. To solve this issue, we simplified prerequisite logic to and only, keeping the design clean and manageable. We added a strong foreign keys and a unique constraint to block duplicate enrollments. We also reordered the table creation script and added the correct undelete rules to prevent the foreign key conflict. This solution helped us build a stable and reliable database. At the end, thank you so much for watching our demos. If you have any questions, let us know. I hope you have a good day.